Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Wormholes, Chaos Construction by King of Fries. And here are the rules. We have regular Sudoku rules apply, which means in every cell in this grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is going to be constructed. We need to place the digits 1 to 9 in 9 groups of orthogonally connected groups of cells to be determined by the user. However, so this is normal chaos construction in that sense, but there's a little catch of that. Normally, to be orthogonally connected, so I say normally because you have to be able to go from any cell in the region to any other cell in the region. And just by going through edges, and you should be able to stay within the same region. So this is a valid orthogonally connected region. This is not, because if you were trying to go from here to here, the problem is that you would either have to go through a corner or you would have to go through another region to get to any other cell in that region, and that's not allowed. But there will be a little wrench in that too. So keep that in mind. Cells with a gray square are even. So all the gray squares are even. And cells with a gray circle are odd. So all of these are odd. And the grid is filled with wormholes. Each square marks a wormhole entrance. So each square is a wormhole entrance, and each circle a wormhole exit. So each wormhole goes through enters through a square and ends up in a circle in the grid. Cells connected by a wormhole are considered orthogonally adjacent. So say this square and this circle were considered the wormhole entrance and exit for one of the wormholes. They would be considered orthogonally connected, orthogonally adjacent. So aside from going through edges, you can also go through wormholes. So say this square essentially is connected to this circle here. Then this is a valid orthogonally connected region, because you can go from any cell in this region to any other cell in the region through edges or wormholes and stay within the region. So that's the reason why I made that example. Also, the number in each circle and square, each square and circle, determines the number of connected cells on that side of the wormhole, which are in the same region as the square and the circle. Oh, interesting. So the circles are always odd. So this actually works. This could be 3, and this would be 6. Obviously, this could not be part of... Oh, interesting. So this would have to be 6 also if it were part of the region. So obviously that wouldn't work. So you're necessarily restricted to 1 circle and 1 square in each region. Or are you? No, that's not true. Yes, you are. Because you can only have 4 unique digits possible. If you had 3... Actually, you could have 3. Huh. This could be 1. No, it can't be 1. You could just have a random 1 somewhere, right? Oh, but then the square and the circle would have to be the same digit, and they're not, obviously, because one's odd, one's even. So yeah, every section you can only travel. Every region can only travel at most through one wormhole. If you tried to have two, the problem is that you would have to have the same amount because each circle and square shows the number of is basically counts the number of connected cells on that side of the wormhole which are in the same region. Anyways, also we also have another one where a region may not border itself. So this is not. That's interesting. What does that mean? I guess that means it can't be something like this. This is not valid. Or I guess actually just even this is not. Yeah, this is not valid. Right? You cannot connect to the same region. So say instead of going there, the wormhole actually just goes through here. This is not valid then. So even though this is a 9-cell region here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can go through edges here, the problem is this would basically go through a wormhole here and would connect to itself essentially. These would essentially the problem is that these would have to be the same digit, and obviously they couldn't be, right? So oh, interesting. Huh. Cells that border an X are in different regions, so these must be different regions, and sum to 10. Cells that border a V are in different regions and sum to 5. So for example, if this were a 3, this would have to be 2, and this would have to be 7, and they're all in separate regions too. Cells that sum to 5 or 10 that are not marked share the same region. So if you have a 3 and a 2 here, or 3 and a 7 here, actually, say you had this combination. These would all have to be the same region, because any cells that sum to 5 or 10 that are not marked share the same region. And finally, the cells that border the white diamond have a different parity and do not share the same region. So we know this is odd, so this must be even then, if that's the case. Because the cells that border the white diamond have different parities, and since this is odd, this must be even, and they do not share the same region. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's draw some borders, because we have a lot of border information. So cells that... So, all of these are going to be, obviously, the edge. Any circle and square cannot be the same region, because then it would border itself, right? So if you enter a wormhole and you exit out that wormhole, it would have to be essentially a... Why is that way? Anyways, it would essentially have to be different regions, because they would have to be the same digit otherwise, right? Just because of the way that the number in each circle and square determines the number of connected cells on that side of the wormhole, which are in the same region. So they would necessarily have to be the same sum. So this is the same. V's and X's are in different regions. These are different regions. This is a different region. This is a different region. Different region, different region, different region, different region, different region, different region, different region here, different region here, and different region here. This is also a different region. Oh, that's interesting. Because, again, you can't have two circles be in the same region because they both count the same amount. So this is its own separate region, so it's 1. It must be within 8 somewhere. Well, we have 4 even digits in row 1, so these are all 2, 4, 6, and 8. The rest of the digits in row 1 must be 1 through 9. Odd. Okay, so this is part of this region here. So we're going to mark that as light. This is, we don't know. It's not necessarily. This, same here, we don't know. This is a separate region here. The 1 has to be with an 8, interestingly enough. This cannot go to here, because then it would border its own region. These cannot be part of this region here. Oh, this has to be at least 2. So this must be, we're going to mark this as dark. This must be at least 2. So this is separate region than this. So this is a separate region. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 wormholes. We should have 8 circles. 1, 2, 3, 4, 5, 6, 7, 8 wormholes. Okay. So this is at least 2. 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 Okay. Obviously this can't, none of the circles can be 9 because you can't have 9 on the same wormhole, because that means there would have to be a corresponding square which has 9, but it can't have 9 ever. This is 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, but they're not guaranteed an 8, whereas we do have a guaranteed 8 here. This adds up to, so this is, these add up to 5. This cannot be 1, and it's odd. So this must be 3, this must be 2. So this can't be 2 here. This has to be an 8. So we are guaranteed an 8 here. We have another 8 somewhere in one of these 3 squares. So therefore, we are guaranteed another 1 in one of the circles. We're not sure where, though. This can't be 1. It's 5 or 7. This has to be 5 or 7 also. So this must go this way. This is 8. Interesting. This is 5 or 7. This is 5 or 7. Okay, this square cannot go anywhere else. This is at least 4. So it has to go to here. This is, we're going to mark as separate. So this is definitely a border. Because it cannot, you cannot have squares in this, you can't have any shape in the same grouping. You have to have a square and a circle in every region except for 1. And they cannot be in the same region as another square or circle, or grouping as another square or circle, I should say. Okay, this is 2, 4, 6, 8. This is 2, 4, 6, and 8. This has to be 1 through 4, so this is 6 through 9 here. This cannot be 2 or 3. Okay, this is 1 through 4, because it's around a V. Let's mark all the 1 through 4s that we can. This cannot be 1 or 4, it's 2 and 3. Not 2 and 4. 2 and 3. So this is a 2-3 pair, which eliminates 2 here, so this can't be 8. So this is at least 2. So these 2 must add up to 10. Because there's an X in between them. But this can't be 4. If this is 4, that means this has to be at least 2, but these 2 add up to 10. So that won't work. So this must be 2 digits exactly. This has to be 8 digits. So I guess we have it. There's no other place that can go here. So this is 4. This is 9. This is a different polarity. So it's 2, 4, 6, or 8. This is a separate region than this. Okay, so this 8 cannot be with this one. So this 8 probably goes with this one, though it could go to here or here, possibly. We don't know. Where can this... Okay, this can't be 2 or 8. This can't be 2 or 8. This is 4 or 6. So that's going to go... Huh. Guess we'll make this pink and this green, then. Anyways, this is 4 or 6. It must go out here. So these are separate regions. This is separate region. This could be a 1 here. It could close off here. So we're guaranteed this is... Yeah, this can't be... And this has to go out here, at least. And then this has to go through here. Therefore, these two don't have any other options except to be part of that region. It's 8, too. Remaining digits in column 8 are what? 5, 6, and 7? Yeah. 5, 6, and 7. This is 1, 2, 3, 4. This is 6, 7, 8, and 9. This is 4, 6, or 8 here. This has to be 1, 5, or 7 here. Okay. 2, 3, 2, 3. We'll have 1, 2, 3, 4 here. Let's not make this orange yet. So the 2 has to be with a 7 somewhere. This cannot be a 4 and 6 because that would eliminate all possibilities for that cell. So this can't be 4 and 6, therefore this can't be 1. This can't be 2 and 8. It's a 4, 6 pair here, which eliminates 4 and 6 in the rest of the column. So this can't be 1, 4. It's 2, 3. That must be with 7 or 8. This 2, 3 pair eliminates 2 and 3 in the rest of the column, so this can't be 3. This cannot be 2, 8, 3, 4, or 6. So it's 1, 7, or 9. If this were 7, this would force this to be 3, so it's not allowed. Therefore, this is a 1, 9 pair, which eliminates 1 and 9 in the rest of the row. This can't be 1. This can't be 4. This can't be 9. Okay. This is 1, 3, 5, or 7. This cannot be 4 and 6. Cannot be 1 and 9 because of the 1, 9 pair in the row. So this is either 2, 8 or 3, 7 here. So... If they were both odds, that would mean 6 odd digits in column 4. So one of them has to be a 2, 8 pair. So this cannot be 2 and 8 here. This must be 1, 3, 4, 5, 6, 7, 9. But we don't know which, right? This can't be 5. This is 6, 7. It must be 2, not 2 or 3, 3 or 4. The rest of row 3 has to be 2, 4, 6, 8, and 9. This can't be 2, 4, 6, or 8, so this is a 9, which means this can't be 9, these can't be 9 here. It's 2, 4, 6, 8. Okay. This 9 eliminates 9 here, so this is 1, this is 9. This can't be 1 or 9, it's 5 or 7. That makes this 5 or 7 too. Hmm. Oh, this can't be 1, so that can't be 4 and 6. So this can't be 1 and 9, which means this is a 2, 3, 2, 3 pair, which eliminates 2 and 3 in the rest of the column. So this can't be 2, this can't be 3. Okay. What else do we know? If this is 6, it has to go here. This becomes a 1. And this, so... Um... Hmm. This cannot be 4 and 6 because that would eliminate all possibilities for that cell. So this must be 3 and 7, which means this can't be 7, this can't be 7. Guess we'll not color that red yet. Okay. We have one region which doesn't have a wormhole. Every other region has to be part of wormholes, essentially. This is 2, 4, 6, or 8 here to add up to 10. We have a 2, 4, 5, 6, 8 quadruplet in column 7, which eliminates 2, 4, 6, 8 in the rest of the column. That leaves these as 1, 3, 5, 7, 9. So no 9, 1, 3, 5, 7, 9, 1, 3, 5, 7, 9. We have a 2, 3, 2, 3 pair in rows 6 and 7, which eliminates 2 and 3 in the rest of those rows. So this can't be 3. This can't be 3. This can't be 3. This can't be 2 or 3. Therefore, this is a 1, 4 pair, which eliminates 1 and 4 in the rest of this column. So this can't be 4. This can't be 4. This can't be 1. So this has to be at least 3. And again, it cannot border its own wormhole, so this must be, well, we know these are different. We don't know this is different. So this must be 3 here. I guess we'll mark it with a different color for the circles. This means this has to go out this way. So this has to go there. It has to go to here. It cannot connect to here because then it would be the same number in the same region. This must connect out this way, so this is pink, which means this is different. Okay, so it is. This is different, this is different. This has to be different too. So it could be, that's interesting. So either, so either this is 4, in which case this is 6, so it has to go this way, which means this would have to go here. This could be at most 1. and or this is 6, and then this is still blocked. So this is either way, this is 1. So it's its own region, right? If this is 6 here, that means this has to go out this way. This can only go here. It can't go any further. It would be only 1 then, because since it's odd. If this is 6, it blocks off this, and this has to be 1. So either way, that's 1. This cannot be 1 and 9. This becomes a 2-3 pair, which eliminates 2 and 3 in the rest of this row. So this can't be 2, this can't be 8. This is 5 or 7. It has to expand. It could expand this way, but it has to get to here. So we're going to mark that as a different color set. Right, it has to go out here. This has to get out here. This can be at most 1, 2, 3, 4, 5. I guess it could be. It doesn't have to be here. But we're guaranteed... No, it can't do this, because then these would both be 4 in size, and that's not allowed. So either this is 6, in which case it goes out here, or this is 6, in which case it goes out this way. So either way, it does have to go here. This green has to essentially go down, because it needs to expand somewhere. This is 3 at least, then it's a separate region. So it has to go out this way. So these are the same region, so that's its total. So this is done. This has to expand out this way, because there's no other place for it. Yellow has to... This is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you only have... Wait, there's more than that. 1, 2, 3, 4, 5, 6. Okay, yeah. I forgot to include this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, no. Not including these. There are 12. This medium dark region probably goes to there. And in fact, it could be one of these two also. Let's see. So there are guaranteed there's 2 other that are non-gray or non-pink cells here. So one of them could be green. That means we're guaranteed at most 4 here. So this must be the other yellow. So that means these are boundaries, definitely. Obviously, this is a boundary here. So the green has to continue on to here. Now it could go either these ways, one of these ways. So this can never be 5. This has to be 1. So this is 1, which means this must be green here. So this is green. It cannot touch this one. It cannot touch this one. It needs a 1 to be part of its universe. So this cannot be part of here. It cannot be here. It has to touch here. So this cannot be green. So it cannot go this way. This could be part of yellow. So this is either... this cannot be part of this one, so it must be part of here. So this is medium gray. So we've got 1, 2, 3, 4, 5. We need a 2. I'm just gonna, it cannot be, it could be part of this, no, it can't. If it's part of that, if this is part of this light gray, or part of this pink. Okay. We have a 5, 7, 5, 7, 5, 7, 4, 6. This is 2, 4, 6. We have to have another 8 somewhere to match the 1s, right? We have 3 1s currently. These match those. There's another 1 here. Where is the 8 then that corresponds to it? So this can't be 4, this can't be 6. This can't be 8 because this can't be 2 because of the 2, 3 pair in the row. And this is not 8 because of this 8. So this has to be 8, which forces this to be 2. This is 3, this is 2. This is 8. This cannot be a 2, 8 pair. This can't be 2, 3, or 8, so this must be 7, which makes this 3. So this can't be 7, this is 5. That means this is 7. So this can't be 3. This can't be 2 or 8, so this is 6, which means this can't be 6. This can't be 6, and this can't be 6. The rest of column 6 is 3, 5, 7, or 9. And this 1 eliminates 1 here, so this is 4 and 1. That means this can't be 4. This is 6. This is 4. This can't be 4, 6, so this is 2. Ooh, we have a problem here. Ooh, that's not good. That's bad. That's very bad. What did we do? How did we screw this up? Let me, restart this. Okay. Whoops. No. Kept the time, so it's good. Ugh. A region may never border itself. Okay. The number in each square and circle determines the number of connected cells on that side of the wormhole, which are in the same region as the circles. Yeah. Cells that border an X are in different regions. Cells that are in a V are in different regions. So we can mark all those, all those. I think that's still correct. I don't know. I have to figure out where my logic was wrong. I have not been doing well recently. Anyways. Yeah. Circles and squares cannot be in the same region because they count the number of connected cells on that side of the wormhole, which are in the same region, and a region may not border itself. So this must be separate. This has to be separate. These are separate. This is separate. This is a 1. That must be with a V, so this is 4. This is 9. This has to be a 2, 3 pair here. This is again 1 through 4, 1 through 4, 6 through 9, 1 through 4, 6 through 9. This is odd. So, yeah, this must be a 3, and this is 2, this is 8. This is 6 or 8 here. This is 2 or 3. Again, these cannot be the same region. This is at least 2. This can't be 2 or 3. This is 2 or 4. If it's 4, it would have to be part of that, so that's another reason why this is 2 and 8. So this is dark. It's its own region. This is 8. It cannot expand here. This is its own region. This is 5 or 7, 5 or 7. We have 4 and 6 here. 4 and 6, 4 and 6. This must be part of its own region. This is 1, 3, 5, or 7. It cannot be 4 and 6 because that would eliminate all possibilities for that cell. This has to be 1, 5, 7, 1, 5, 7. This has to be a 4, 6 pair since they're both even. We have 8, 8. 1, 3, 5, or 7. This cannot be 4. So this can't be 1, 4. It's a 2, 3 pair, which makes this 7 or 8. 2 and 3, 2 and 3, eliminate 2 and 3 here. So this is a 1, 4 pair. This is still the same. This can't be 4, so this can't be 1. That seems okay. It was really that this closing here. Okay, so this is at least 4. This has to go out here. So these must be this. Oh, this doesn't have to be. That was the problem. This doesn't have to be. This one does. This one's blocked. So this one has to go out this way, but it doesn't have to. This has to still continue out. Okay. So this is a separate region. Mark that as pink. It has to go out here. It cannot be touching the same region as the circles. So that was the problem here. So this can't be 1. This is at least 3. Okay, that made a big difference. This has to be at least 3. So it must go down to here. Therefore, these are borders. But that's it, right? This has to go pink here. It could expand this way. This, though, does have to go this way. This is 3 at least here. It could be those 3. That was the bad assumption that I made. So we have 1, 3, 5, 7, 9 still. This actually wasn't that hard, but anyways, this can't be 3. The remaining digits in column 2 are 1, 5, 7, 9. This can't be 1. This can't be 9. This can't be 5. These must add up. It cannot be 7. This is a 1, 9 pair. This is 2, 4, 6, 8. Okay, this is 3 digits. This is pink again, so this is 5. I guess this could go this way, though. This can go... So this could be 4, and this could go 6 this way. That is possible. This is 1, 2, 3, 4 as possibilities. So this is 6, 7, 8, 9. This can't be 9 here, so this can't be 1, which means this can't be 4. This can't be 1 because of the 1, 9 pair in the row. So this is a 2, 3 pair here, which forces this to be 7 or 8. We have 2, 4, 6, 8 here. The rest of column 8 is 5, 6, 7, so this is all the same. So this was the bad assumption here. This has to be 3 and 4 here, that it cannot be. That made a big difference. This can go out this way, right? So this does not necessarily close off here. This is at best 3, though. So this is 1 or 3. This adds up to 10. It cannot be 4, 6, so it's 1, 2, 3. Cannot be 1, 9. This is basically 2, 3, 7, or 8. Oh, we have a 1 or 3 here. This is 2. One of these is 2 or 3, and this is 1, 2, or 3. That eliminates 1, 2, and 3 in the rest of the column. So this is 4, 5, 6, 7, 8, 9. This can't be 8 because one of these is 2 and 8, adding up to 10. So this could be 1 or 3 here. Okay. This can go out that way now. Whereas before, I had to go that way and it was blocked. Technically, this could go this way. So, Actually, well, it could go here too. This has to continue out here. So we'll mark these. This is definitely green. This is definitely that. So this could be 3, or it could be 1. This could be... Yeah, since we don't have that anymore, that's not restrictive. Anyways, okay, let's look at the rest of rows. I don't know. We have 5 or 7 here, 5 or 7 here. This cannot be 4 and 6 because of that. So this must be 3 and 7. That means this can't be 7, this can't be 7. This can't be 7, so this can't be 3. This is 1 and 2 with 3 and 4 here. Um... Hmm. That could go out this way. Hmm. I was wondering if this could be 5 or 7, but it could be. Can this be 5 or 7? Maybe. Actually, it can't be 7 anymore. So it's 1 or 5. This is 2, 4, 6, or 8. So we have a 2, 4, 6, 8 quadruplet in column 7, which eliminates 2, 4, 6, 8 in the rest of the column. So we have 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, and 1, 3, 5, 7, 9. But these can't be 3 because of the 2, 3 pairs in the row. This can't be 9. This is still fine. So I'm marking this as green again. Can it go this way? Yes, but it does have to go down. Right? I guess, no, it cannot cut off this 5, right? This has to be at least... Can it be this way? You could, actually. So this we don't know where it goes to. Could go to here. Could go to here. We just don't know. But it has to be at least 5. So that means it expands to at least here. Which means this has to go to here at least. We're guaranteed. Otherwise, there's no way else that it can go. Since it goes there, this has to be blocked as a boundary, so that's there. It could do something like this, though. So it doesn't have to go down here. So this could be 5 that way. That's fine. We have a 5, 7, 9 triplet in row actually a 5, 7 pair in row 3, which eliminates 5, 7 in the rest of the row. So this is 9. That leaves 1, 2, not 1, 2, 2, 4, 6, 8 as the remaining digits in row 3. Okay. So this green has a 9 already. That means this can't be 9. This is 1, which forces this to be 9. Okay. Oh, interesting. If this is 1, this is 4, that makes this 6. Okay. So what does that mean? If this is 1, this is 4, this is 6. That means this is 2 and 8, which means this can't be 2 or 8. That would force this not to be 1, so this has to be at least 5. Would have to come out here. This would have to come out this way. This would be 1. This would be its own region. Could be its own, yeah, it could be the... Okay. That would make this 1. This could not be 2 and 8. So this would be a 4-6 pair, and this can't be 4, so this is 6, this is 4. This would be 6. Oh, actually, that is one interesting thing that we know. This can't be 4 or 8. So these two must add up to 10. So this cannot be, oh, this can't be 4 anyways. So this can't be 6. This must correspond to here. So this is the same digit as that. This is 2 and 6. This is 4 and 8. Because these add up to 10. These two must add up to 10 then. So we have that. 1 and 4 cannot be there. This is 1, so this cannot be 1. This can't be 1 or 9, so it's 5 and 7, 5, 7. Hmm. The rest of row 2 has to be 3, 5, 6, 7, 9. 1, 3, 5, 6, 7, 9. Okay. This can't be 1, though, because of the 1, 4 pair in the row, or in the column. These can't be 2 or 3, because of the 2, 3 pair in the column. Why did this block off everything? Okay, so we know this is a border, obviously. Huh. Remaining digits in column 1 are 1, 4, 5, 6, 7, 8. Do we have any other restrictions? Not particularly. Why did this blocking off cause a problem? Because then this had to go here. Then it had to go here, so this was at least going down here, which forced this to go here, so this couldn't go here. So this is 1, but then this would have to be part of the green. Since it was the part of the green, why was that bad? So this would be 1. That would make this 4, this 1, this 6. We had, okay, so this part had to be part with this. This blocked off here. So this was guaranteed 1. It had to be part of this. We needed another 8. So far, that's okay, right? So how did we eliminate... Okay, this couldn't be 4, 6. How did we eliminate this, essentially, as a possible... Oh, this was 1. That forces to be 2, 8. Aha, and that's the problem. That's kind of convoluted. Jeez. Okay. I'm not sure how you figure that out without going through down that path, but If you do go in that path of going this, that means this must be essentially 12 here. That means this must go down at least to here. And this is a 1 guaranteed. So that forces this to be 2, 8. So this couldn't be 8. But this being a 1, this being blocking down here meant this had to go here, which means this is blocked, cannot be 5. So this, therefore, it has to go down here. This is 1, that's 4, this is 1. This is 4, 6, so this couldn't be 4, 6 here. So this would be 2, 8, but this 2, 8 here forces this not to be 8. Therefore, we'd have a 1. We'd have 3 1s without a possibility of having a 1. So this cannot go down this way. This has to go specifically this way. Even if this is 5, that also fails, right? Because of that contradiction. So this must be 3, and it must connect to here. That's interesting. So this is a boundary. That means this cannot be 3 here. The rest of column 6 is 2, 5, 6, 7, 8, 9. But this can't be 2 here because of the 2, 3 pair in the row. Okay. So this could go down here and block that as long as this is still right. So that's possible. What it cannot be is this is 1. This blocks off this way. So I think you cannot go this way, right, as pink. You can't contain both. If you contain both, well, it could be 4 even, though. Okay, so what happens if this is 6, then? If this is 6, then you should have a similar problem, right? Yeah, because then the yellow forces this to be here. Green has to go here, so this is 1. This is 1. That makes this 2, 8. This is 4, then this is 1. That makes this 4, 6, so this can't be 4, 6. This is a 2, 8 pair. But the 8 here means this can't be 8, so this can't be 8, and therefore this 1 doesn't match. These 1s don't match up with a corresponding 8 in the square, which it needs to. So this can never be 6. This is guaranteed to be 4. This is 6 then. So this is remaining there. Therefore, this can't be 6 here because of the region it's in. This can't be 6 either. This is 4. This can't be 4. This can't be 4 now. This is 6. It cannot go 2 here, because then that forces the same problem here. And then this would be 1. This has to go... This. If we go 2 here, this is at most... It has to go down to here, which means green blocks off this circle, so this is 1, and all the rigmarole again occurs. So this must go at least 1 this way. So this is a border, obviously. This must go down to here and is medium dark. So this is a border here. 1, 2, 3, 4, 5. It could go this way. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it could do that. This can't be 3 because of the 3 in the column. So either this is 5 here in some way, and this is a 1, but the green can go out here. Or this does block, this does block here, but then this is 3. And then this, that would be 2, 8, this would be 1, 9. And this would be 1, 4. This would be 6. This would be 4. Oh. Huh. It's problematic either way. Interesting. So, if this is 1, 4, this becomes 6, and this can never be 4, 6. If this is 2, 8, that means this is 3, 7. This is 1. That's interesting. Okay, so if this is 1, 4, this is 6, this is 4, this is 1, this is 5. So this is 7, if that's the case. This is a 2, 8 pair. So this would be 4 and 6 here. And, oh, that's interesting. Okay, so if this is 1, 4, if this is 1, 4, this is 6, this becomes 4, this is 1, that's 5, right? So let's go through. 1, 4 makes a 6, 4, 1, and that's 5. This cannot be a 4, 6 pair. It has to be a 2, 8 pair. This can't be 1 or 5. This is 7. Therefore, the circles, this would have to be a 1. That wouldn't work. This 1 would force this to be 3, and the 8s would not have a corresponding... One of the 8s would not have a corresponding 1 to be with, specifically this one. So this cannot be 1, 4 because of that. So this must be 2 and 3. This is 8. This can no longer be 8. This can't be 2. This can't be 2. So this can't be 3 here. There can't be a 2, 8 pair. This is a 3, 7 pair, which eliminates 3 and 7 in the rest of the column. So this is 1. This cannot be 8. If this is 1, that makes this 4, which makes this 6, which makes this 2, 8, which makes this 4. And then we'd have 3 1s without a corresponding 8 to be a wormhole to. So this cannot be 1. This is 5 then. This is 7, which makes this 8, and 2, which makes this 3. This can't be 5, 7, or 8. No 5, 7, or 8. This is a 1, 6 pair. This is 5 it has to go through. So this cannot be green. This green has to go here, at least, to expand out. That means this has to be sort of yellowish. Obviously, this has to be. This... Yeah, you need at least this one. Okay. I guess we'll mark this as red here. That means this must go out here, so it's basically all of that. So this is 5. This is bordering here, so it has to go out here. So this red has to go out here. That means this is a boundary. This green has to continue out this way. This can't be 7. This is 5, which forces this to be 7. This can't be 5, 6, or 7. It becomes a 4, 9 pair here. Hmm. We need a 1. This can't be 1 anymore. This can't be 1. These can't be 1s here. This cannot be 3, 7 to add up to that, to add up a 10, because that would eliminate all possibilities for that cell. So this is 2, this is 8. That makes this 3, so this is 7, 3. This is part of the green, so this can't be 7, this is 5, which makes this 7. Can't be 7 here, here, and here because of that. This can't be 3 or 5, it's 1 or 7 here. Remaining digits in row 4 are 1, 6, and 7, I think. No, 1, 4, 6, and 7. This can't be 7, though. Okay. This is guaranteed to be the same digit as that. And actually, it can't even go this way. This can't be 8. This is a 2, 6, 2. We have a 2, 6, 2, 6 pair in column 6, so that eliminates 2 and 6 in the rest of the column. We can't have an 8 anymore. This gray has to go this way. It's blocked because you can't have repeats in the same region. So it's 1, 2, 3, 4, 5, 6, 7, 8. So this is all that region. We only have a 1 next to that, so this has to be 1. This has to be the green one. So those are all, well, the green's not done, but the gray region is done. We have a 1 here, so this can't be 1. This is 7. We need a 9 in the region, so this is 9. We need a 3 in the region, so this is 3. 3, 4, 5, 6, 7, 8. Wait, we have 2 9s. No, we have a 9 in the region. Okay, so this is 7. This can't be 7 or 9. We don't know what these are then. We have a 2, 6 pair in row. Okay, this can't be 6 because it's part of the pink, so this is 2. It can't be 4, can't be 8. Right, so this is 2, which makes this 6. This can't be 2 or 6. This 6 eliminates 6 here, so this is 5, which eliminates 5 here, so this is 3, which eliminates 3 here, so that's 2, which makes this 3. Okay, yeah, that matches that. This is 7, this is 1. Remaining digits in row 5 are 2, 4, 6, 8. This can't be 2. So these add up to 10 also. This can't be 8. This could be 4, 6. So this is all that pinkish region. Okay, obviously it doesn't correspond to that one necessarily. It has to go to one of these two. Huh. And in addition, this 7 has to correspond... Okay, so this 7 corresponds to a 2 somewhere. Well, the only 2 possible is here, so this must be 2 and 8. Therefore, we're going to mark this, I guess, as blue. Maybe we'll mark it as orange. No, we'll mark it as blue. This is the only possible other 2, so this has to be 2. It cannot go here and border itself. And it cannot go here to go with the other 7, so it has to go down here. So this goes here, this cannot include 7. It could include here, it could include here, we're not sure. This must be 2 and 8 guaranteed. That means this can't be 8, this is 4 and 6. So we should have corresponding 5s and 7s then. Right? So we have how many 1s and 8s? We should have 2 1s and 8s, we do. We have 2 3s. That means we need 2 6s. So this must be a 6 here. So this is 6, this is 4. We have 1 4 and we have 2 4s and we should have 2 5s with it. Yes, we do. Okay. So these are all set. This can't be 7 because of the 7 in the column. This can't be 7 because of 7 in the row. So this must match this dark one here. So we'll march that color, and it goes it cannot go here. So this is part of some other region. I think it has to be its own region, right? We're gonna mark this as orange. So this cannot contain 7. Okay. This gray region must go to a 5. And this, well, technically it could go here. What do we need access to if it were to go there? We need an 8. So I guess this could be 8. This 6 goes with a 3 somewhere. Cannot go to 3 here, so this must be the pink one. So this can't be 6. This is 1, which makes this 6. That means this can't be 1. Can't be 7 here. This can't be 1. This is 4, 6 here. This can't be 4 or 6, so this is 2. This can't be 4 or 6, so this is 8. Dark region has... So the dark region needs to have... The remaining digits are 1, 5, 6, and 9. Well, this can't be 5 or 6. This can't be 5 or 6. This becomes a 1-9 pair, which eliminates 1 and 9 in the rest of the column, the rest of the region. This can't be 9. This is 5 or 6. Oops. So this 2, this blue region needs to have... Okay, so this is all done as a region. This 2 needs access to a 5 or a 6. Well, it can't have 5 or 6 in any of these cells, so it must be here, and it must be a 5. So this is a region this is the region for that tomb wormhole. That makes this not 5 here, so this must be 5 here. That means none of these could be 5. We have a 7, 9 pair now in row 2, which eliminates 5, 7, and 9 in the rest of the row. So this is 6. This is pink going with this. The red has to be part of this red. So this is red, red. This could be light, or it could be with the orange. So this is orange or light. We're not sure which. This is orange or light. We're not sure which. Obviously, light cannot be here. So orange, light. This could be orange, though. And any of these two could be green. And this could be pink. Well, cannot be pink because that's a 2. So this cannot be pink. Therefore, we know the size of this. This has to go to here. And that's pink. So this is 8, which means this can't be 8. This is 4. This has to be 8. We have 3, 1, and 9 in the pink, so this must be 7. This must be 5. This can't be 5 anymore. This 7 eliminates 7 here, so it's 9. This can't be 5 or 9, so this is 1, which makes this 9. We cannot have a 9 in the red, so this is 4, this is 9, and this can't be red, so the red has to continue out this way. So the dark cannot go here. 4, 5, 6. That's problematic, because this has to go down here. This is not part of our region then. Ugh, what did I mess up? Jeez. So this isn't actually hard for the logic. It's hard to just basically make sure you don't mess up. I think it was pretty solid up until I started combining regions. Or maybe it was here. I don't know. Yeah, the problem is this can't form a full region by itself, right? Hmm. Uh... This is 1. This can't be 1 or 9, so this is 5. This can't be 5 or 9, 7. This can't be 9, it's 5. That makes this 6. This can't be a 1-9 pair. So we have problems. Yes. Hmm. Technically, that would be 8 and 4, which would make this 6 and 4. Hmm. I think this assumption's still valid. I think I have to get to before that assumption. Hmm. Again, this cannot be. It has to be 1, 7, or 9, but the 7 would force this to be 3, so this definitely has to be 1, 9. Is this a safe assumption that this has to be 4? So say we'll make this 6. Let's just say. That means this goes down here. This is 1. This yellow has to go here, so this green has to go here, and it blocks that off. So this has to be 1, which makes this 4, 1, 6. Same thing, right? So then this is 1. Then this is, yeah, this has to be 2. Okay. Right, this is the same problem, right? 2 and 8. So this can no longer be 4, 6, or 8. This is 2 and 8. This is 4 and 6. So where do the wormholes match? We have 8 and 1. 8 and 1. We need another 8 to go with the 1, but we don't have it. That's why it cannot be 6. So I think that logic was all correct. The problem is that we're running into an issue here. So this is 4, this is 6. Right? This has to go this way at least once. So neither of these can be 6. This can't be 6 because of it. Well, we already knew this one couldn't be, and this one couldn't be. Um... Hmm. Because again, if it goes, we're running into the problem here of this is this 12 cells here. So this can only contain 2 here, so it would have to go here. This is 5. That forces this to be 1 by itself, at least. That makes this 4, 6, and then 4. And then this is 3 and 2, 8. So that's a contradiction, right? This can't be 4, 6, or 8. This is 2 and 8. This is 4. And we have 3 1s, which we don't have access to a 3 here. Sorry, we don't have access to 3 8s in the corresponding wormholes, which it must be. So that means this can never be 1. This has to be 5. Since it's 5, can the green ever go here? It could. Oh, maybe that was the bad assumption. Okay, maybe that was the bad assumption. This can't be 5, this can't be 4. It goes here, but it could go up here. This could go this way. I don't know why I included that as green. Yeah, 5 could go here. I don't know. Yeah, that was probably my mistake, actually. Hmm. That's interesting. Okay, well, that's where my mistake was. I guess we can't go this way then. Hmm. That's interesting. The green does need to go out here, though. There's no other place for it, but it could go this way. So that was the bad mistake there. So this could go here. Okay, that's probably where yeah. That's probably the error that I made. Okay. This is 5. One of these is 5. And one of these is 7. I don't remember how we did the other one. Okay, so this, even if it's this, it cannot, it's blocking here. Right? It cannot go out this way, down here. So it has to go out here. Either whether this way or this way. Either way, this has 5 here at most, so this is a 1. So this is, not 0. This is 1, this is 2, 8. That forces this to be a 3, 7 pair. That eliminates 3 and 7 in the rest of the column. This can't be 7, this is 5, this is 7. This can't be 5, 6, or 7. So it's a 4, 9 pair here. This is 5. This is 7. This is blocked here. So this must be medium gray down to here. Since this is 3, 7 here, this can't be 3 and 7. This must be 2 and 8, which forces this to be 2. This can't be 2. This is 3. That makes this 7, which makes that 3. So this can never be 3. This medium gray can never go this way. It has to go this way, and this 7 needs to continue on there. So this has to be, so this is still all the same. That's 8 cells. We're going to mark this as blue. Actually, we don't know that yet. This can't be 2. This is 6. This is 4. This cannot be a 4, 6 pair. It's a 2, 8 pair. But this can't be 2. So this is 8, which makes that 2. That corresponds to a 2. Cannot correspond to this 2. So we have all the 7s. We need 2 7s to match the 2. So this must be 7. Because we don't have any other circles with 7s there. So this cannot match with this because you can't border the same region. So it must be here. This can't be 3 or 7. Again, this matches with a 1. It must match with this one. So this one's green. So this is 1. This is green. This can't be 6. This is 5. That means this can't be 5 here. You can't have a 1 in the region. So this is 7. This can't be 1 or 7 or 9. So this is 3, which makes this 2. This is 3. This 2 eliminates 2 here, so it's 3 and 2. This can't be 2 anymore. This is 6. So this can't be 2 or 6. This is 4 or 8. This pink cannot go down here, so it must continue here. So that's that region. The pink cannot go, has to go with a different 3 than this 3 here, so it must be, this is pink. Therefore, this cannot be 8, this is 4. This can't be 1, no 1 here. This 5 eliminates 5 here, so this is 6. This can't be 7 here or 7 here. This already has an 8, 4, and 2. This can't be 8 or 7. It's 1 or 6. Neither of these can be 7. This is 8. This can't be 8 or 7 anymore. Again, we'll mark this as... So this cannot... It connects to either 3... So it has to be with this blue. Right? If it tried to connect 7 here, it can't go... Well, it would have to connect here. It would border itself, which is not possible. So it must go this way. And it can't go both of these, so it has to go here, then down here. So that's all the same. This is a boundary. This must go up here, because it must contain a 2 and one of these digits. So this can't be 1 or 3. This cannot be 9 here. This can't be 6, so this is 1, which makes this 6. This can't have a 1 then. This is a 5, 7 pair, which eliminates 5, 7 in the rest of the column. So this is 1, 6, 8, 9. 6 can't be here. 8 can't be here. This can't be 6 or 8. Where is the 8 in column 5? It has to be here. So this can't be 8. We have a 1, 6, 9 triplet here. We have 2 8s with the 2 1s. We have 2 2s with the 2 7s. We have 2 3s. We have to have a 6 here, and this must be a 6 then. And then we have to have 2 5s with 2 4s. So this is 6, this is 4, which makes this 3. We already knew that, actually, though. This can't be 6. Where is a 6 in column 5? It has to be here. So this is 6. This can't be 2 or 6, 7, 8. So it's 5, 9. This can't be 6. This can't be 6. So this cannot match here because that's not 1 or 4. It must be here. So this is a region by itself. This then has to be a sort of a region by itself here. So this is yellow. We're marking this as red. This has to have 7. So we know it goes out this way. We have 1, 2, 3, 4, 5, 6, 7. It has to go out here. So this must be yellow too. So this is all yellow, which means this is the edge of a region. This must be the dark. So it must be part of dark. 1, 2, 3, 4, 5, 6. It cannot block this way. It can't have 4 and... We already have a 4 here, so that forces this to be 9, this to be 4, so it must go this way. So this is dark. This cannot be 6 or 9. This is 5. That makes this 5. So that all works. This is the edge of this region. That means red has to go this way. 1, 2, 3, 4, 5. That means this is a region by itself. It's orange or light. So this, we're marking this as orange. This has to be orange here then, because this is a separate region. 1, 2, 3, 4, 5, 6. This must be green. So this is orange or light. And this can only be orange, not pink, orange or green here. Green could be any of... Actually, green has to be here, right? Yes, so this has to be green here. Which means this is orange or light. This can't be light because it touches there. It would border itself. So this must be orange. That means this is not orange. This is light. So we have the full regions now. Okay, that was kind of painful to get those regions. Apologies for that mistake. Anyways, this 4 eliminates 4 here. That makes this 8. This is matching here. This 4 eliminates 4 here, so it's 1. This is 4. we have a 1-9 pair, which eliminates 1 and 9 in the rest of this region. So this is 5. This can't be 5. This can't be 5. This can't be 5 because of the 5 in the row. So this is 7. This is 5. That makes this not 5 or 7. So this is 9. That makes this 7. We already have a 5 in the region. And a 7. And this is 1 here. So this can't be 1. So this is 9. That makes this a 6. This 7 eliminates 7 in that region. So it's 5 and 7. This can't be 7. No 5 either. This can't be 9 because of the 9 in the region. And what color is this? This is the other 6, which is red. So this must be 1, which makes this 9. That leaves these digits. We have 1, 2, 3, 4. It's 5 and 7. This can't be 5 because of 5 in the row. So this is 7. This is 5. That leaves this as 1. This as 4. This digit has to be a 1, so this can't be 1. This is 9 and 1. That leaves this as a 9. We're missing a 2 here. This can't be 2, so this is 2. That makes this 8. This has to be 4, and this is a 6. Not 6, can't be 6. We are messing up somewhere. Okay, gray, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. Orange, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. Pink, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. Red, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. Gray, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. Dark. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then blue. So this is 9. This can't be 2, so this is 2. Green, we're missing a 4, so this is 4. This is 8, and that's 6. I don't know. It was just messing up. I just messed up in the normal Sudoku. This was fun, but I kept on making too many mistakes. Oh, that's the theme for today. Like I've done some other puzzles and I've been making some pretty bad mistakes, and it's not the same. It's basically the same here too. This wasn't as bad, but they weren't as egregious. But I don't know. I think I'm done for the day because my brain is not working well today. Hopefully it works better the next couple days so that I'm not making any really bad errors, which I have been. I mean, this was a pretty these were some pretty bad errors here too, right? With the this assumption here. This one, I don't know how I basically colored that in as green. That was weird. I even said it too. I said it could go this way or it could go this way. And yet I still just basically, I don't know, I made it green. It was very strange. Yeah, but yeah, that's the solution. Um, yeah, I wish I had done a better job. I didn't do a good job today for any of the puzzles that I solved. So, kind of disappointed in myself. Anyways, I hope you enjoyed this solve though. And I'll see you next time on Frank Puzzles. Take care.